Okay, it's not enough, guys, for us to generate a linear model, no? A multiple linear regression model on the variable of interest sa outcome variable natin. Kasi we have to test and check whether our model is acceptable. Kasi may mga assumptions ang multiple linear regression, and here are some of the examples. Here are some of the assumptions which we have already discussed. So sabi natin, model fitting is just the first part of the story for regression analysis. Okay, we know that linear regression is based on certain assumptions. So when we have generated the model, we have to test and check whether the assumptions are followed or are complied with. Otherwise, if not, baka may mga problems tayo dun sa kung acceptable ba yung model natin, acceptable ba yung coefficients. Okay, so sabi natin before that dapat yung model natin blue, no? It should be the best linear unbiased estimator. Okay, so some of the assumptions are linearity, no? So dapat yung relationship between x and y should be linear. Okay, kasi kung may parabolic or quadratic na sila, then we might have to introduce some powers of the independent variables. Kunyari, baka naka-x squared dyan, o naka-x cubed, o naka-x fourth, etc. Okay? So in that case, hindi na siya magiging linear kasi naka-squared or cubic na siya sa x, no? Another issue, guys, is dapat yung mga residuals natin, yung variance niya, dapat constant across all observations. Kung hindi siya constant, ibig sabihin, merong aspect ng dependent variable natin na hindi ma-capture ng model natin. So kunyari, if the residuals have a trend, pataas yung residuals, ibig sabihin nun, may upward trend, may upward movement na hindi nakaka-capture ng model natin. Kasi dapat yung residuals, dapat they should be random and dapat yung variance sa constant. Ibig sabihin, hindi nag-i-increase over time or over the values of your outcome variable, or hindi siya nag-i-increase over time or hindi siya nag-decrease over time. Okay? Next is independence. Dapat yung natin, yung independence in terms of your independent variables, dapat walang relationship sila, no? And also normality, dapat yung residuals natin, dapat normally distributed. Okay. So there are ways to check this, no? There are ways to check this. So let me just go first through the text para hindi ako nag-jump, no? So isa sa test na tinitingnan natin is the R-squared. Tinitingnan natin, gusto natin malaman kung yung model ba natin can explain the variance, the variability of your outcome or response variable. Okay, kasi sabi nga natin, di ba, yung may assumption tayo sa linear regression model that the relationship between our predictors and our outcome variable is linear. Okay, baka hindi totoo siya, baka quadratic or so baka hindi siya linear, baka logarithmic siya, no? Or baka polynomial siya or exponential. Okay. Also, we have to look at possible outliers, extreme values, or influence data points. Importante yan, guys, yung influence data points, the presence of which affects the parameters, the coefficients. Pag tinanggal natin yun, mababago yung value ng mga coefficients. That's what we mean by influential points, no? Yung outliers are values that are outside yung IQR, no? Nasa labas siya ng IQR natin, but that doesn't make them influential. Okay, so pwedeng may outlier pero hindi naman influential yung point na yun, okay lang. Pero pag influential, guys, yun ang dapat tingnan. Okay, so therefore, kailangan talaga ng diagnostic sa regression. Kunyari sa paper nyo, it's not enough, guys, that we generate the model. Kailangan we have to do diagnostics. Okay, so for this one, gagamitin natin itong mga ano na to, mga packages. Tidyverse. Tidyverse is a package consisting of several other packages. Tidyverse, Broom, Datarium, where we will be getting our data, Dplyr, Fortify, OLSRR, which we used before, Stargazer for results, for beautifully generated results in table forms. Tapos ito for ggplot din yung pag-set ng plots natin. Okay, so let me request you to run this. Pag kunyari wala pa kayong package na Datarium, so install niyo muna, no? I'll just require this. So since na-install ko na sila, guys, hindi ko na kailangan i-install, i-require ko na lang. On your end, guys, i-check niyo muna. You can run this one by one. Kung wala pa hindi pa nakita yung package yan, paki-install. So I'll give you a few minutes for that. And then once you're done, guys, pakisabi na lang na sa chat na finish na, so that I know when to continue. Pause share ko muna. Paki-remind ako, guys, sana pinost ko yung recording. Okay, let's wait for the others. Okay, kindly require the packages. Yung OLSRR, guys, we used this before, di ba? For yung pag-generate ng stepwise regression. Marami pang functionalities yan, especially sa regression residuals. I think yung RR dito, ordinary least squares regression residuals. So marami pang capabilities to as regards diagnostics. So it will be good, guys, for you to look at this package kasi hindi lang siya used for stepwise. Okay, thank you, Samya. Thank you, Richard. So, hintayin na natin ng konti si Ina. Okay, thank you, Ina. All right, so, okay, so gagamitin natin, guys, yung data ng marketing coming from the Datarium package. So, i-run natin to. Okay, so makikita natin dito na okay. Dapat naka-promise na dito siyan. Promise, no? And then i-view natin si marketing. So simple lang yung data na gagamitin muna natin. Just to highlight yung diagnostics. Ang gagawin natin ngayon, guys, we'll just focus on a simple illustration. Just a simple linear regression muna. So which means hindi natin mako-cover lahat ng diagnostics, no? Kasi may sa simple linear regression wala naman dong issue ng multicollinearity, no? Kasi yung multicollinearity if your independent variables or explanatory variables are correlated, yun ang multicollinearity. Pero since we're going to start first with diagnostics for a simple linear regression, so this is our data, 200 observations. You have here sales, okay, sales, YouTube, Facebook, newspaper. So ito yung sales, and then these are the costs that were used to advertise their product sa either sa YouTube, sa FB, or sa newspaper. Okay, so what we want to know is kung kaya nating i-predict yung sales using this, yung advertising or promotions media nila, no? Itong YouTube, Facebook, at saka newspaper. Pero initially, guys, magsisimple linear regression muna tayo. Okay, so let's, okay, hindi ko natikinin yung head. So ang structure nito, so apat yung variables natin, 200 observations. Okay, so lahat sila numeric, that's okay. And then summary. So you have the minimum value, the maximum, okay? All right, so brief descriptive statistics lang. So, all right. First, let's start with a very simple model. Yung i-regress lang natin si sales on YouTube using the data marketing. Okay, and then let's create a regression model, FIT1. Run natin to. Okay, so we can see here the output ng ating simple linear regression. Ito yung formula. Tapos you have a measure of the residuals, minimum and then maximum, median. And then ito na yung individual test of the coefficients. You have YouTube is a significant predictor of sales, no? Significant at 0.001, tatlong stars dito, no? So ito yun, significant at 0.001. And then it's able to describe or explain around 61% of the variability of your price. Ibig sabihin, the rest of the variation could be explained by other variables. Okay, so you know this already, guys. Alam na natin mga yan. Simple linear regression lang. Ang objective natin dito is to diagnose, no, yung model natin si FIT1. So alam natin yung yung laman ng FIT1, okay? Andiyan yung coefficients, yung residuals, effects, etc. Fitted values. Okay, we can view that actually, and then it will give us a list. Ito yung list niya. Then we can click this. Tapos makikita natin ito yung intercept at saka ito yung slope ni YouTube. Okay, residuals, this will give us yung difference ng, if I click this, yan, okay? So this is observation number 1. Ito yung error, no? This is the difference between your actual and your model. Actual versus model yan, 4.955. Okay, so let me go back now here. Okay, i-close ko na tong fit na to. All right. So, for this one, pinapa-print lang natin yung residuals, first 3, tapos naka-round off, first 3 elements of the residuals variable. Okay. May nag-run pa ba? Okay, yan. Taking so long. Yan, okay? So ito, ano to? 1, 2, 3, 4, 5, 6. Okay. Head pala, no? Head, so first 6. Ito yung first 6, ano natin, ng residuals. Okay, pina-round off ko na lang into 3 decimal places. Round, tapos comma 3, ibig sabihin 3 decimal places. Ganun din yung mga fitted values. Okay, so ito yung predicted values. If we're going to take a look at marketing, yung sales niya sa first observation is 26.52. Using the model, na-generate natin, ang predicted value niya is 21.56. So if you subtract, ito, copy natin to. Control C, Control V, or actually pwede natin gawin ganito, no? Para talaga naka-code, no? FIT1, ito yung model natin. FIT1, okay? $, and then Tatakpan siya. Ulitin ko. Fit 1, dollar, fitted values. No? So ito yung predicted value, guys. Okay? So there are 200 observations of fitted values kasi 200 yung natin observations natin. But I just want to get the first one. No? So ito yung una. Ito yung unang fitted value. If I run this, 21.56493 yun. Okay? Ito yung predicted value. For example, ito, tira natin, diba yung 21.563 yun. Tapos, so fitted value minus ano yung actual value niya? Yun natin. So marketing, yung sales, marketing, just toying with this marketing. Tapos yung sa sales, then again yung first yung first value lang. Kung kunin natin difference yan, guys. Okay. See? So yung fitted value minus yung actual value, or dapat yung actual value minus yung fitted value. And then i-compare natin siya dun sa fit 1. Okay? Dollar sign, residuals, and then yung first. Okay, yan, no? Na-confirm natin. Tama nga, no? We're just confirming kung if we're going to manually compute for the residual, yung deviation between the actual value and the fitted value, we will get 4955071. Okay? All right, question dito, guys. Question. This is also meant to enhance our capabilities sa paggamit ng R. Any questions about this one, guys? I just wanted to prove that tama nga yung residuals, 4.955. Kasi ang ginawa natin, kinuha natin kung tutuusin dapat Control C, Control V. Dapat yung actual value Control X minus, okay. So this is the actual value minus the forecasted value, fitted value, and 495. Okay. All right. Pause muna ako. Questions, guys, so far? Clear naman, or am I going fast?
Okay naman, sir, so far.
Okay, thank you. All right. So we can, of course, we can get the goodness of fit testing sa F statistic by the ANOVA. No? Iba yung ANOVA na diniscuss natin last time. This is small a. This is what we call a type 1 ANOVA, where the null hypothesis is, since simple regression lang tayo, ang null hypothesis dito, sulat ko lang, beta null is equal to beta 1 is equal to 0. Kasi dalawa lang naman yung predictors natin. Well, isa lang actually, ito yung intercept. So, small a yon, guys. Iba yung big A kasi type 2 yon, yung big A, yung ginawa natin last time. Kasi we're dun sa big A, tinetest natin some values dun sa independent variable natin. Okay, but I won't discuss that now. Actually, medyo partially na-discuss natin siya last time. Nung nag-interaction. Okay, let's run this. And then this will generate the analysis of variance. Okay, ito yung degree of freedom. Okay, 1 kasi isang predictor to. Residuals is n minus k minus 1. So that's 200 observations minus k, yung number of predictors, minus 1 to compensate for the lost degree of freedom because we're also computing for the intercept. No? So ang F value is 312.24. P value niya is practically 0, significant at 0.001. Therefore, ang conclusion natin dito, we reject the null hypothesis that beta null is equal to beta 1 is equal to 0. So there's a strong probability that at least one of these is not equal to 0. So yun ang ANOVA natin, no? Yan, ang tawag natin dyan, goodness of fit test. Okay. So ang model natin guys, ito sinulat ko na, no? Our model is, kasi yung, so let me go back to our model here a while ago. Kasi ito, no? 8.439 at saka 0.047. Yun yung ano natin, yun yung coefficients, no? So our sales is equal to the intercept plus the coefficient ni yung slope ni YouTube, no? Plus a certain error term. Okay? So so far guys, what we have done was just to stop here. Whether it was a simple linear regression or a multiple linear regression. Hindi pa tayo last step, which is to analyze the residuals. Of course, guys, pag in-interpret natin to, dahil when we do a write-up about this, yung APA format, sasabihin natin a simple linear regression was conducted with sales as your dependent variable and YouTube as your independent variable. Okay? So sasabihin natin na yung useful stuff when we analyze that a 1 unit increase in siguro dollar to, dollar advertisement, $1 increase in YouTube would yield a 4.7% malamang dollars din yan, increase in sales, ceteris paribus, so etc. So that's just the interpretation of that model. Okay, analysis of residuals. Dito na guys. So simple lang muna tayo, simple linear regression. Pero the same principle guys applies for multiple linear regression. Okay. So tingnan natin to. I-plot natin guys. Okay. So wait, no? So we're going to create a variable. Take note guys, marketing to, no? Di ba may object tayo ng marketing? 4 yung variables niya. So dollar residuals, ibig sabihin, mag-i-insert tayo ng panibagong variable na ang tawag residuals. And then, ira-round lang natin yung residuals. So this is a function. Residuals ng fit1. Yung fit1 natin, linear regression model natin, di ba? And then, 3 decimal places lang. So ganun din, we're creating this object called predicted, another variable to. And then round them to 3 decimal places, yung predict values, yung fitted values based on this fit1 model. And then what do we do here? Okay, so dito, ang sabi dito, marketing, and then select natin, ibig sabihin ng select guys, ito yung ipapasok natin, select natin itong variables na to, no? Sales, YouTube, predicted, residuals. Ibig sabihin tatanggalin natin si Facebook at saka si newspaper, no? So ang papasok lang dun sa bagong data set na to, si sales, si YouTube, si predicted at saka si residuals, and then pinapaano natin yung head. Head is the first 6 observations. Sige, let's run this first. Itong dalawa muna, tingnan natin, control enter. Okay, and then when we look at marketing, tingnan natin marketing guys, tingnan nyo, meron nang nadagdag na dalawang variables, di ba? Dalawang columns, residuals at saka yung predicted. Okay? All right, and then ito, i-run natin to, isang code chunk lang to. So using dplyr, guys, marketing muna, and then pipiliin niya si sales, YouTube, predicted, at residuals. Ang mangyayari dito, yung select function, guys, it's used to choose kung ano mga variables ang gagamitin, ang isasama. So dito, ang isasama lang si sales, si YouTube, si predicted, residuals, and then pinapaprint natin yung first six observations. So let's run this. Itong last na to. Okay, so, oops, ano nangyari? Sabi, error in sales, YouTube predicted unused. Bakit unused? marketing, and then select si sales, si YouTube, predicted residuals. Okay, and then yung head niya. Tama naman. Error daw. Nag-run sa inyo, guys?
Yes, sir.
Nag-run sa inyo? Bakit hindi kaya sa akin? Marketing, okay? Tapos, ay, wait. Oh, okay na, may predicted na eh. Yung marketing ko, meron ng predicted at saka residuals. Yan. Residuals at saka predicted. So here, I'm going to select only, ang papapasok ko lang si sales, YouTube. Okay, si sales, si YouTube, and then residuals, and then predicted. Sales, YouTube, predicted residuals, and then yung head lang i-print niya. Okay, how about you guys? Kindly comment guys kung nag-run sa inyo. So dapat may lumabas na dito first 6 sales, YouTube, predicted at saka residuals. Paki-comment nga guys kung if you were able to get it. Kindly chat please. Nag-run. Okay, mukhang sa akin lang hindi, no? Okay, anyway, so it should contain, I'm wondering why yan. Dapat nag-run to. Okay. Select, sales. Last try ko na lang, ha? Okay, wala pa rin talaga. Okay, anyway, what's important is nag-run sa inyo, no? Okay, good. I'm having a problem here. Bakit hindi siya nag-run? Okay, now ito guys, this is medyo complicated yung ano guys, no? Yung code natin dito, but it's actually simple, no? So let me just explain to you. This one, ggplot. So this is from the package ggplot2. Ang data na gagamitin natin, marketing. Okay, and then ipa-plot natin si YouTube na nasa x-axis, si sales nasa y-axis. Always guys, yung independent variable natin yung nasa x, I'm sure you know that. And then yung dependent variable natin nasa y. And then magpapaplot tayo ng geom smooth is parang yung regression niya, no? Method is equal to LM. Standard deviation, standard error is equal to false. And then color is equal to light gray. And then magdadagdag tayo ng geom segment. Mga lines to. No? Ano ipapaline niya? So sa end ng x-axis, no? So di ba yung x-axis, yung x natin YouTube. Sa end nun is YouTube. Sa y-end, yung predicted value. So bale, magdodraw siya ng ng line, no? Ng line from the predicted value down to the actual value. Okay, yung actual value ng YouTube, and then magla-line siya from the predicted value. So makikita natin yung vertical line na yan, yung error terms yan. Kung ano yung deviation niya from ng actual value to the predicted value. Okay, tapos linagyan natin ng color, yung mga points na yon, size at saka may konting jittering, opacity. And then maglalagay din tayo ng point, no? Yung residuals. Okay, and then scale color natin. Okay, you don't have to understand everything here. And then my guides na color. And then my geom point ulit. Okay, so theme na black and white. Let's just run this whole code chunk. Sana mag-run sa akin. Kanina hindi nag-run. Okay, I think nag-run siya. Okay, so this is a good way to understand ano nangyayari dito sa model natin. Okay, so let me show this to you. Okay. So, di ba guys, ito yung ano natin, yung independent variable, yung sales. Ito yung, ito yung dependent variable natin. Ito yung independent variable natin. So itong line na to guys, this is your regression line. Okay, this is the line of best fit. So itong mga points na to, those are your predicted values, yung nasa line, and then these are your actual values. Diba? So there's a deviation between your actual and your predicted value. So that's the basis of OLS, no? Ordinary least squares. So the line of best fit is the line that minimizes your squared residuals. Kasi ito yung residual natin, yung error term, no? Tapos pag in-square natin yan, and then sum up all of those 200 residuals squared, no? Itong line na to, which is called the line of best fit, ito na yung pinakamagandang line na mag-generate sa atin ng lowest na squared error terms. Wala nang ibang mas gaganda dito. This is a unique line, yung regression line natin. Okay, so pinakita ko lang guys yung yung paano kinukuha si OLS. This is a unique line to. Ito yung regression line na to, yung line of best fit. Unique yan. Wala ka ng ibang line na makikita na ang sum of the squared of your residuals is less than this line. Kapag medyo mag-angle tayo ng konti, kunyari slant ng pataas ng konti, iba na yung SSR nun, sum of the squares of your residuals. Okay, mas mataas na. Ito guys, yung line na to, yung line of best fit, this is the line that generates the most minimum, no? The minimal residuals squared. Okay? So, close ko na muna to. Okay, let's move on. Yung test natin. So, pinakita lang muna natin dito yung plot ng madali guys i-plot kapag simple linear regression. Pag multiple na, medyo mahirap na, no? Mahirap na siya kasi unang-una marami ng variables ang considered, no? Okay. Now we can use the augment function sa Broom. Kaya nga linode natin si Broom. So anong binibigay sa atin ni Broom? So we're creating this object model.diagnostics.metrics, and we're using the augment function from the Broom package, and then we're doing the diagnostic metrics for our regression model, which is FIT1. Okay, i-run natin to. It will generate values. Okay, so hindi nag-generate yung head. Okay. Bakit hindi makita? Run to. Okay. It should run now. Okay, do you have this, guys? Paki-chat naman, please. Ako, paki-unmute na lang kung nag-generate ng isang object na model.diag.metrics.
Yes, sir.
Okay, for FIT1. Okay, thank you. Now, what do you notice here? So ito yung dependent variable natin si sales, ito yung independent variable natin. Isa lang yung sinama kasi ito yung data frame for FIT1. Si FIT1 kasi YouTube lang. Pero remember sa marketing object guys, meron yung YouTube, Facebook at saka newspaper. But what we only use is YouTube. So YouTube lang pinasok niya dito. So what you can find here is ito yung fitted value, ito yung forecasted value, ito yung residual. Okay, kasi sinubtract yung actual value 26.5 minus the fitted value, you have a deviation of 4.96. Ito yung residual. Okay? All right. Tapos let me just discuss this with you. Yung Cox distance. Yung Cox distance, guys, ginagamit to for determining whether your observation is an influence points. No? influence point. Sabi natin kapag influence point, ang inaano niyan, ang pinapakita sa atin kung if that data uh, if that data influences the coefficients. Kung tanggalin natin data na yan, malaki yung ano malaki yung magiging difference dun sa coefficients natin. Okay, so that's for generating this. Okay, if you need a table where you find here the dependent, independent, tapos yung mga fitted, tsaka residual, at saka yung Cook's distance, at saka yung that hat is, I forgot what that, standard error yata to. Okay, I think this is standard error. So, but we can check, no? Sorry, hindi ko maalala kung ano yung that hat. Okay, so let's, okay, so dinidescribe ko siya dito, fitted values. Ito pala guys, sorry ha. Okay, yung that hat, ginagamit siya to detect high leverage points or extreme value. So, ang use niya is for the determination of your Cook's distance. So, ito yun. Okay, so meron din palang standard that residual. These are your standardized residuals. And then Cook's distance, which is used to detect influential values. Okay, so ito yun, no? All right, so moving on, guys. Just by quick review, di ba, yung assumptions natin, linearity of the data, normality of residuals, homogeneity, independence of your residuals, dapat yung autocorrelation yan, dapat yung residuals natin hindi correlated to each other. Tapos yung independence din ng ng independent variables natin, dapat hindi sila correlated. Ito yung assumptions ng classical linear regression model. Now, dapat i-check natin yan guys, yung mga assumptions na yan. Okay? So, pag nababiolate yan, it might affect our model. Kunyari, yung kapag heteroscedastic, yung ano natin, which means yung variance natin, kunyari may trend siya, or nagfa-fan out siya, okay, or nagfa-fan down siya across the observation. So may problema yung model natin. Okay, kahit na yung presence of influential values in the data or outliers. So lahat ng mga to guys could affect our model. So there's a need to look at them. Okay, and yung mga diagnostics ito guys, some they're not all created equal. Kunyari, yung normality ng residuals. Okay, between normality and heteroscedasticity, mas grabe yung impact ng heteroscedasticity. Okay, yung normality of residuals, kapag malaki yung dataset natin guys, okay lang yan. It's okay. So mas mabigat na problem yung multicollinearity at saka yung heteroscedasticity. Those are the bigger issues when we do diagnostics regression. Okay, so let's create the plot. No? Let's create a plot, guys. I'm not sure if we generated this before, pero itong plot na to, guys, ibibigay sa atin yung mga relevant na plots as far as the diagnostics is concerned. Okay, guys, 1 minute lang. I'll just get water. Okay, so so ipapaplot natin guys si fit1. So this function plot will generate some plots on diagnostics. Okay, so ipapartition natin. You have 2 rows and 2 columns. So let's plot this. Okay, so ito yung ano natin, no, yung diagnostics. Okay, so we can see here yung residuals versus fitted. This tells us guys kung ano ba, kung may linearity ba tayo, kung linear ba yung relationship ng y at saka ng x natin. Okay, for normal, this is for yung normality ng residuals natin. Tapos itong scale at saka itong residuals versus leverage, it tells us kung yung ano natin homoscedastic or heteroscedastic yung ano natin, yung distribution ng residuals natin. Okay. So may mga guidelines, may mga konting ito pa pala guys. You can also use this ggplot2 yung package, then may auto plot function. Actually mas gusto ko to, no? Auto plot, and then i-run natin. A little bit, medyo mas maganda lang yung konti yung ano niya. Okay, medyo mas maganda lang konti yung ano niya, yung how do you call that? Yung ano niya, yung pagka-print kaysa dun sa isa. Nangyari dito. Yan. Oops. Wala. Wala siya sa ano. Anyway, okay, meron naman dito, no? Okay, so let's okay, actually guys, meron pang ano, no? Ito, I also like this kasi yung isang package, yung GG Receive panel, this is a also a powerful package in terms of diagnostics. Okay, so I'm introducing it here. Meron din, we can also plot this. Kaso, mas marami pang pwede natin ipasok dito sa residual plot, no? So dito, nag-create lang ako ng 1, 2, 3, 4, 5, 6 na plots to. Tapos dito naman, dito ipapa-all ko siya. So let me just show you the power of this package. Now, ito dati wala pa tong receive panel na to, guys. So over time, kaya nobody really becomes sabihin natin expert sa R. Sabihin natin may very comfortable tayo in using R. Pero kasi laging may nagko-contribute ng panibagong codes that improves the output. So dati plot lang eh. Tapos nag-GG plot. Tapos ngayon, recently na-discover ko tong receive panel na medyo bago lang to, no? So let's check first. Okay. GG receive receive capital R, tapos just check the spelling. Ito. Receive panel, no? Yan. Okay, so let me check. Okay, kayo guys, paki-install na muna to, no? Sorry, hindi ko siya nalagay sa taas, no? Okay, bakit wala? Dito na muna, dito ko tingnan sa packages. GG. Receive. Yan. I'll click this. Okay. And then ito. Right. Please tell me guys kung na-install nyo na. I'll wait for you.
Okay, yes.
Okay, thank you. The rest? na, no? Nag-chat na pala. Okay, thank you. Now, medyo relatively bago lang to, May lang to ng 2019. So barely 2 years, no? And magti 3 years na pala. So what can we find here? Panels and interactive versions of diagnostic plots using ggplot2. Okay, so this is what this is all about, no? Para sa pag-generate ng kasi ggplot2, we know, guys, that's the parang yan tour de force sa data visualization. Yan ang pinakamagandang package in terms of data visualization. Tapos tingnan natin ito yung gagamitin natin, itong receive.panel. Okay, pwede rin yung receive.compare, no? Panel of diagnostic residuals across multiple models. Ito pag maraming models. Okay, ito receive.panel, receive_panel. So ito yung syntax niya, no? Yung model, yung plots, okay? Smoother is equal to false or true, etc. So ito yung syntax niya, guys. And I really learn a lot, guys, pag tinitingnan ko yung documentation. So ang ginagawa ko kadalasan, kinakopy ko to, tapos nag-experiment ako. And may example din dito, no? And you can run these examples, no? Ito, naalala niyo yung penguin natin. Iba ba to? Yeah, I think parehong data to, no? Penguin model. Tama. Yung ginamit natin dati. Did we use that, guys, here? Penguin na data set. Do you recall, guys, penguin? O hindi? If not, guys, sorry minsan nalilito ako dun sa kung saan ko ginamit ko anong class. Okay, so anyway, guys. So let's just quickly take a look at this plot. As I said to you guys, mas preferred ko itong ginagamit yung receive panel. So let me just access this. And then here, we're creating a panel, no? Ang model natin yung fit1 natin. Yung mga plots dito, linagay ko yung QQ plot, histogram, residual index. Ito yung Y, yung actual versus the predicted, and then yung cook distance, no? Sa histogram, ang bins na 30, tapos smoother is equal to true. Ito yung smooth line sa sa LM, and then ito yung QQ bands true, and then the type is equal to standardized. If we run this, so animang ibibigay sa atin ng plots dito. Yan. Okay. So, and it's for me, it's quite it's better than yung lang kanina, no? Ito yung natin, no? So ito, guys, this will tell us that visually makikita natin dito kung nababiolate ba yung mga assumptions ng OLS, no? Ordinary least squares. For example, yung QQ plot natin, makikita natin dito kung yung residuals ba natin is normally distributed, kasi that's one assumption. Pag medyo nag-veer away siya dito sa quantile plot na to, itong 45 degrees na to, no? Then that means, guys, na yung residuals natin hindi normally distributed. Visually, guys, mukhang okay lang naman, although may mga deviation dito sa outer, sa left side, sa right side mas konti, but looks okay, no? Looks okay visually, no? So pati dito, guys, sa makikita din natin normality dito. So since standardized siya, okay, mukhang naman, mukhang although yung height niya medyo malaki, but it's okay, guys, no? Mukhang normally distributed naman yung residuals natin. Okay, so each one of these plots have their own role, no? So ito yung index plot na to, anong sinasabi nito? Standardized residuals versus your observation number. This tells us din, guys, kung yung linearity ng data natin. So itong parehong to, pwede natin tinan to in terms of linearity of the data. Dapat, guys, yung red line natin dyan, dapat dito lang, katabi lang ng blue. No? Hindi siya masyadong lumalayo. Okay? Dito din, okay? Medyo, although dito sa lower values ng predicted values natin, medyo may dito, no? Medyo malayo dun sa horizontal line. Okay? And then this one is a test of homoscedasticity or heteroscedasticity, no? Mukhang may guys, may problem yung natin, no? Yung residuals kasi hindi siya constant. Diba? Over a wide range of over a higher range of your predicted value, medyo yung variation niya, no? Lumalaki. Dito sa maliliit na predicted values, hindi malaki yung variance. Pero pagdating dito, guys, diba? Malalaki na yung so this is what we call a fanning out. Fanning out. Tapos, itong Cook's distance, it will identify kung ano yung mga values na pwedeng influential points. Okay, so mas mas comprehensive pa dito yung next. Dito kasi sa next, guys, ang pinaplot ko all. So 9 lahat yan, no? 9 lahat. Ang difference lang niya, itong plots ko, hindi ko in-itemize dito in-itemize natin, di ba? Yung 6. Dito all, so it will generate a plot. Run natin to. Okay, so ito guys, 9. No? Okay, 9. So yung 6 kanina andi dito din, may mga nadagdag lang. This is the box plot of your standardized residuals. Location, and hindi yata natin pinakita ito, no, kanina. Ito yung residual plot natin guys, yun, no? Okay, so this is indicative that heteroscedastic yung residuals natin. Ganun din dito, no? Okay, so I gave you some notes. Okay, una yung residuals versus fitted. So it's from here, no? Dito yun. Let me close this first. I'm using now my reference as my reference yung plot lang natin, yung plot. This one. Oops. Ay, sorry. Dapat kasabay ito. Okay. Okay, itong discussion sa baba, guys, it's for the first, it's for the plots using the plot function, the base R plot function. So residuals versus fitted, if you take a look at this, guys, straight line siya, di ba? So yung red natin, mukhang ando doon naman siya sa straight line. So ang comment natin dyan, a horizontal line without distinct patterns is an indication of a linear relationship. So this tells us, guys, visually, that there seems to be a linear relationship between your sales and your predictor, which is YouTube. No? So mukhang okay naman siya. Wala namang pinapakita na baka dapat may may curvilinear, dapat may quadratic or polynomial, wala namang ganun. Okay, and then as I mentioned, guys, itong normal QQ plot natin, okay, normal QQ plot tells us if our residuals are normally distributed. For the residuals to be normally distributed, dapat andun sila sa quantile line na to, no? Ito. Dapat walang deviation, no? Walang deviation from the QQ line na to. So looks like okay naman siya. Mukhang normally distributed naman yung residuals natin. But of course, guys, as we go along, itetest natin statistically. So ano lang to guys, visual ano lang to, visual aid lang. It doesn't mean na yun yung conclusion natin kasi we know guys that others might interpret this differently. So mahirap yung ganyan kasi magiging subjective yung interpretation natin. However, if we couple that visualization with yung statistical test natin, metrics, then mas sabihin natin mas how do we say that? Mas rigorous yung ano natin, yung interpretation natin. Kasi may statistical test tayo plus data visualization. Okay. All right. So others guys, others dito yung scale location or spread location. Ito yan. Ito. So what does this measure? Yung scale or spread location. If we take a look at this, ang pinaplot dito yung standardized residuals, no? Yung square root niya. Okay, what are standardized residuals? Iba yung residual siya, tapos sinubtract natin yung mean, then dinivide natin yung standard deviation ng residuals natin. So that's what you mean by standardized residuals. And then get the square root of that. And then i-aano natin dun sa predicted values, ipa-plot natin. Okay, what do you have here? Ano yung interpretation natin kapag scale location ginagamit? Okay, it's used to test kung yung residuals natin homoscedastic or heteroscedastic. We would want the line to be horizontal, no? Okay, horizontal line with equally spread points is a good indication of homoscedasticity. This is not the case in our problem, no? As I mentioned a while ago, mukhang may problem tayo sa residuals natin, no? Kasi ito, guys, okay, unang-una tingnan niyo yung yung plot ng yung range ng square root ng standardized residuals natin. Okay? It's increasing over higher values of your fitted values. Okay? Tapos ito, kita niyo line natin, hindi siya horizontal. So this is indicative of a heteroscedastic distribution ng error terms natin. Okay, and then we have here yung residuals versus leverage natin. Ito yung fourth natin. Residuals versus leverage. Ito. Okay, what are we plotting here? Ganun din, standardized residuals at saka leverage natin. So may definition ng leverage. No? So this is used to determine kung may mga influential points tayo. Meron tayong mga leverage points. Tapos usually naka-number yan. So ito parang mga candidates yan. 26, point number 26, point number 100. Is this 176? Para may isa pa dito. Ano? Okay, so mas makikita yan pag zoom natin. Okay, so what will this tell us? Okay, ginagamit natin yan for influential cases. Influential observations. Kasi sabi nga natin, di ba, kapag ang isang observation is influential, it could affect yung ano natin, yung regression model natin. It could affect the parameters, yung coefficients ng ano natin, regressors. Okay? So discuss pa natin yan later on. Okay? And then linearity, guys. Okay. So punta na tayo dito. No? Okay. So clear so far to guys yung ano natin, yung mga diagnostics natin using this plots. We've learned, guys, how to also use yung GG resid plots natin where we're able to generate, diba, mas maraming plots. Where's that? Ito, no? Ito yung GG resid panel natin. Okay, so let me run this again one more time. So ito, guys, mas maraming plots na i-generate nito, no? Pero ang nadagdag, ito nadagdag, di ba? Histogram nadagdag yata, parang walang ano doon, walang histogram. And then yung index plot. Is it the index plot or the hindi, ito palang response versus predicted. So this is your Y versus your Y hat. No? Okay, so let's take a look at them one by one very quickly. So first, yung linearity of the data natin, makikita natin sa first plot na yan, which I already discussed. So if you want just to generate the first plot, ito lang yun, plot, fit1, and then number 1. Yan, so ito yun. Yan, so we already discussed this, sabi natin, this will establish whether there's a linear association between your dependent variable and your independent variable. Diba? If the red line is practically a horizontal line, then ibig sabihin nun, there's a linear relationship between your y, your dependent variable, and your independent variable. So as I mentioned here, ideally the residual plot will show no fitted pattern. Okay, kasi ang pinaplot natin dito, yung fitted values at saka yung residuals. So this is a plot of your predicted values and your residuals. No? So dapat wala siyang pattern. If the red line should be approximately horizontal at 0, then kung hindi ganun guys, the presence of a pattern may indicate a problem with some aspect of the linear model. Okay, so although ang sinabi ko dito, there seems to be a fanning out. May konting fanning, ayan no, may konting fanning out. Okay, may fanning out, pero that will be an issue as far as the variance of your residuals is concerned. Pero as far as the linearity of the relationship between x and y, mukhang okay naman siya. Okay, then let's go to the other plot, guys. Ito number homogeneity of variance. Ito number 3. No? Run natin yan, number 3. Okay, so ito yung binanggit natin kanina. Ito yung scale location where we plot yung fitted values on the y-axis, x-axis, and then the residuals on the x-axis, yung square root ng standardized residuals. And again, guys, sabi natin, ito yung sinabi natin kanina, as much as possible, dapat horizontal yan. Pag hindi siya horizontal, ibig sabihin nun, may issue tayo as far as the constancy of variance is concerned. Okay, ibig sabihin, non-constant yung variance natin. So pag non-constant yung variance natin, pag hindi constant, then that means that our residuals are heteroscedastic, no? Hindi sila homoscedastic. Okay, hindi natin aabutin to. Next time, titingnan natin guys yung how do we address? Okay, how do we address heteroscedasticity, for example? So there are several ways to do this. Number 1, pwede natin i-transform yung data natin. Unang-una, pwede ang ginagawa dyan, yung ilolog natin yung ilog natin yung independent variable. No? Okay, subukan lang natin guys, as quickly lang. Tingnan natin, let's see, kung mag-mod, dito ko na lang ilalagay sa dito sa console. Let's create a model. Let's call it mod 1A, alt minus. And then ELM natin, si log ng sales. Okay. Regressed on ano natin? YouTube ba? YouTube. And then data is equal to marketing. And sama ko na summary mod 1A. Okay, tingnan lang natin guys, may may effect kaya yung kung ilog natin, kasi that's one solution. No? One solution is to transform your data. First, your dependent variable or your independent variable then. Pero usually minsan inuuna si dependent, pero wala naman hard and fast rule doon. And then, okay, pwedeng sabay, no? Pwedeng pare-pareho sila. So para magkaroon tayo ng log linear model, or it can be a linear log model, or it can be a log-log model. Pag sinabi natin log-log, nakalog yung dependent variable, nakalog din lahat ng independent variables natin. Okay? So if I run this, ayan, tingnan natin, significant pa rin, highly significant pa rin yung yung mga predictors natin. But remember guys, sandali lang, tanongin ko nga guys, ano yung magiging ano dito? I-run ko ulit. Arrow up, arrow down, arrow up, i-run ko ulit. Okay. How do we now interpret this? Nakalog na yung ano natin. Nakalog na si sales. How do you interpret si YouTube? Anyone? Take note, nakalog si sales guys. Ha? Anyone would like to volunteer to interpret? Paano ngayon natin i-interpret si YouTube? Kasi hindi na pa pwedeng for every 1 unit, $1 increase in YouTube, there's a corresponding $0.0031 increase in sales, no? Ceteris paribus. So kapag nakalog yung dependent variable, yung outcome variable natin guys, tapos yung predictor natin hindi nakalog, paano natin i-interpret yan? Hello? Anyone? Paano yung interpretation yan kapag log lin? Kapag log din. So dapat aware tayo dyan guys ha, kasi oftentimes sa finance or sa eco, linolog, tinatransform yung data eh. Lalo na kunyari pag mga monetary data, kunyari GDP, GNP, isang population, malalaki kasi yun in billions. No? So oftentimes, kasi pag in-scale natin, if you get the log of that, na-scale yung data. And it's better, it's easier to deal with kapag naka-logarithms. Anyone guys? Anyone? Interpretation ng 0.0031555.
Maybe sir, it's a percentage increase.
Yes. Oh, so paano yan? For every
For every
okay, for every $1 increase in YouTube, diba? There's a corresponding
3% increase.
Yes, 0.3%, no? So that should be 0.3% increase in the price and the sales, no? And then ceteris paribus. So guys, tingnan nyo na lang ha. Although hindi ko pa yata dadaanan yun, but please check, ang dami naman references sa internet, how to interpret, paano kung log yung ano natin, log yung dependent variable, log din lahat ng mga independent variables natin. Or log lin, ano naman yung log lin? Log yung dependent, linear yung mga independent natin. Or lin log, ano naman yung lin log? Hindi nakalog yung dependent, ang nakalog yung independent variables. May combination naman, yung log linear, log yung dependent, tapos some of the independent variables are combination siya ng log at saka ng linear. So it's important guys for us to know how to interpret yung coefficients kapag ganun yung kapag ganun yung model natin. Okay, so let's see. Okay, let's see kung ano nangyari sa ano. Ano nangyari, i-plot natin, gamitin na lang natin tong natin dito. Okay, actually ito pwede na to, no? Ano ba ginamit natin? Mod pa rin ginamit natin, hindi fit, ano? Sige, anong mod 1A, okay? So let's see. Control C, Control D. I'm going to replace this by mod 1A, yung model natin. Mod 1A, okay? So let's plot this, okay. Okay, ano nangyari guys? Tingnan nyo. Compare this one, okay, with this one. Okay, what happened guys to the linear, to the log model? Di ba medyo nabawasan yung upward na trend ng natin ng line dun sa scale location ng yung first model natin compared to nung linog natin yung ano yung yung dependent variable. So there was a marked difference already, no? Naging medyo horizontal na yung ano natin. So pwede rin natin ilog din yung ano, ilog din yung YouTube, no? I leave that to you as an exercise. So what I'm saying here is if you have I'm going ahead of myself, ano, pero next meeting pa natin itatapusin to, no? Kasi hindi natin aabutin talaga sa haba ng discussion na to. If you have an issue with the heteroskedasticity, kailangan i-address yun. So what's one way? One way is to transform. No? One way is to transform your data. Another way, guys, is to correct the standard errors. Eh ngayon, guys, yung mga katulad nitong ano, itong R. Meron na tayo ngayong mga packages at saka mga functionalities na pwedeng i-adjust yung mga standard errors para heteroskedasticity robust na yung model natin. I'll discuss that in detail next meeting. So as it stands right now, kapag may multi-collinear, kapag mayroon tayong heteroskedasticity, hindi blue yung model natin. Hindi siya yung best linear unbiased estimator. So therefore, that has to be addressed. And yung isang pinakasimple na transformation, i-transform natin data natin. Kung pwedeng ilog, then ilog natin. Kasi that could address yung issue ng heteroskedasticity. Okay, so moving on, guys. Okay, so we just compared, no? All right. Okay, ito sinabi ko lang, guys, a possible solution to reduce this is to use a transformation, either ilolog siya or pwedeng i-square root. No? Square root yung, not only the outcome variables, minsan sinasama na rin yung independent variable. Okay. Now, paano ba natin talaga malalaman kung heteroskedastic siya? Kasi visual yung ginamit natin. So, medyo nag-introduce na ako, guys, ng ng statistical test. So dapat may basis tayo, hindi lang pwede natin sa paper sasabihin na the scale location, which is a plot of your square root ng residuals natin and yung fitted values. Okay, dali ha. Ano ba yung natin dito? Wait. Just to check, alam ko fitted values. Yan, tama, fitted values. So square root ng standardized residuals, on the y-axis, on the x-axis, you have the fitted values. So it tells us, guys, as I mentioned a while ago, na hindi horizontal yung natin, yung red line natin na yan. So indicative of problems or issues with heteroskedasticity. But we can test that, no? So merong let's use the package car. Okay? And then there's a function there called okay, yung NCV test. And as usual, guys, maganda kung titingnan natin NCV test. So what's this for? Non-constant variance test. So it's coming from the car package, and then it will sandali. Ito na lang. Packages, minsan ayaw eh. So car package, okay. I'll open this. And then here, hanapin natin si NCV. Dito sure, makikita natin yung letter N, NCV test. Dati NCV.test yan. So dinifunct na yun. Pinalitan na. So you can't choose anymore yung NCV.test. Before I was using this, yung NCV.test. Pero defunct na siya. Ibig sabihin, pinalitan na nito. NCV, capital T. Okay, so what does this do? It computes a score test of the hypothesis of constant error variance against the alternative that the error variance changes with the level of the response or fitted values. Okay, so ang null hypothesis natin dito, ang sabi, constant daw yung error variance ito. Variance of residuals is constant, which is what we want. So ang gusto natin guys, wag natin ma-reject to. Ang gusto natin yung p-value natin greater than 0.05 so that yung distribution ng residuals natin is homoscedastic or constant. Okay, so andito yung syntax niya. Okay, ito. And then as you know guys, may example siya. No? Dito may example siya. All right, so let's go here. So in order to statistically test kung heteroscedastic nga yung ano natin, yung residuals, ito yung gagamitin natin. So i-combine natin guys yung plot at saka yung yung statistical test using NCV test. If I run this, okay, take a look at this guys. Non-constant variance score test from the CAR package. Variance formula, okay, regressed against the fitted values. Chi-square is 42.7, degree of freedom is 1, and p-value is 0.000, practically 0. So, ano to? We reject p-value is less than 0.05, therefore, we reject this null hypothesis that your residuals have a constant variance distribution. So, re-reject natin siya. So, tama nga guys, no? Hindi constant yung variance ng residuals natin ng fit 1, ng model 1 natin. So, may heteroscedasticity nga. Okay? And as I said a while ago, yung next step niyan, i-address. No? Hindi basta-basta, heteroscedastic. So, dapat i-address yan. And there are ways to do that. No? Ngayon nga, mas madali nang i-address yan. Kasi may mga packages na automatically aayusin yung standard errors na. No? Okay, we'll discuss that next meeting. So, ngayon guys, dati nung kinukuha ko pa ito, katakot-takot na computation. No? Kasi hindi naman kami nag-R dati. Pero ngayon guys, madali na. No? It's a lot easier kasi may mga packages na that will do the computation for us. So it's more of understanding lang and knowing how to interpret those things. Okay, there's another test guys. No? So ito, may introduce din ako dito, yung Bruce-Pagan test. Okay, so this is from the LM test, no? Na package. So tingnan natin guys. Although I think inon yung na kanina to, linode nyo. Linode ba natin LM test? Linear model test. Okay, LM, hindi ko sinama. No? So sige, dito ilagay natin dito, LM test. This is also another important, yan, no? So pag chinek nyo yan, ma-install yan, ma-require yan, automatic, no? And then let's take a look at what this does. Okay, so description. Okay, so it's a collection of tests, data sets, examples for diagnostic checking in linear regression models. Furthermore, some generic tools for inference in parametric models are provided. So, an LM test is also a powerful package. No? So, andito yung user guides, vignettes, etc. No? Introduction. Okay. So, hindi ko na titingnan nila yan. I leave that to you guys. Ang gusto ko lang malaman dito, yung BP test natin, guys. Ito. BP test. Bruce-Pagan test. Okay. Ayan. Diagnostic checking. All right. So, may discussion dito, no? May discussion dito. So, I leave that to you guys. Okay. Ngayon, kasi R din to, no? Tapos yung data na to, available siya. Available yung data na to. Tapos, yan, susundan lang natin yan, guys. Oh. Tapos may reset, no? This is now for correcting yung yung mga heteroscedasticity. Okay, so going back here, okay, as I said to you guys, madali na ngayon eh. Let's click BP test. Okay. So what's this for? It performs the Bruce-Pagan test against heteroscedasticity. Okay. Formula, a symbolic description for the model to be tested or a fitted LM object. You know, fit one natin. And then the Bruce-Pagan test fits a linear regression model to the residuals of a linear regression model. Okay. By default, the same explanatory variables are taken as in the main regression model and rejects if too much of the variance is explained by the additional explanatory variables. So may way na may ginagawa tong itong Bruce-Pagan test. Ang HO niya is that the test statistic follows a chi-square distribution with the parameter. Okay. Tapos HO niya, pareho din ng HO nito dun sa NCV test that the variance of the residuals is constant. So may example din dito. See also NCV test. Okay. So going back, guys. So ang ginagawa na natin ngayon, guys, hindi lang importante yung plots, but we have to reinforce that with actual statistical test. So let's do the Bruce-Pagan test. So ito siya, no? From the LM test package, BP test, run natin. And we want the p-value to be greater than 0.05, pero hindi, no? Hindi eh. No? It's less than 0.05. Therefore, we reject the null hypothesis that the residual variance is constant. No? So hindi constant yung variance ng residuals. Therefore, may heteroscedasticity nga. No? Although may kinoment ako dito, guys, na mas robust yung BP test kaysa sa NCV test. So if you're going to choose one, just choose BP test. Okay. So I'll not go there. It's more on how the test statistic was computed. Okay. So far, guys, nag-test tayo ng heteroscedasticity. No? Sinabi natin na it's not enough to plot yung number 3. Okay, yung scale location, pati other plots that tell us about the condition of the residuals, kung constant ba yung variance niya. So nag NCV test, nag BP test, and sinabi natin that the BP test is more robust. So that's why you need to use only one. Pwede na yun, no? Yung BP test na yun. Okay, pangalawa, guys, normality of the residuals. Again, di ba yung natin, yung pinat natin dito. Let's go back here. Diba ito yung QQ plot? Number 2 being QQ plot natin. Okay. Anyway, ito lang papakita ko. Looks like yung natin, yung mga residuals natin, they're normally distributed. But then again, guys, sabi ko nga, couple natin yung plot at saka yung test. Okay? So we can test also for the normality of the residuals. Ito pala, dito na pala. So plot 2, ito na yan, So although dito sa lower values ng standardized residuals, medyo may tayo dito, may deviation dun sa quantile line natin, no? Pero dito sa higher values, okay naman siya. So to statistically test this, gagamit tayo ng Shapiro test, no? Okay. So si Shapiro, ang niya, guys, ang null hypothesis natin dito, the residuals are normally distributed. So just like the homoscedasticity, we want that the p-value to be greater than 0.05. So that's from the stats package, and we don't need actually to load the stats package kasi it comes already with the R. So ito yung Shapiro test. Again, this is used to test yung normality. Okay, but we have to identify here that yung fit one and then yung residuals. Okay, so ito yung kakaiba dito, no? Kasi kanina, yung NCV natin at saka BP test, automatic, fit one lang. Pero dito sa Shapiro test, dapat sasabihin natin yung model at saka kung ano yung value na pinapa-check natin for normality. Okay, check natin to, run natin. Okay, so we have here yung residuals natin. Okay, ito yung Shapiro-Wilk statistic. P-value niya is 0.21. So this tells us that we fail to reject the null hypothesis that the residuals are normally distributed. So as we have guessed, guys, sa residuals mukhang okay naman, no? Mukhang hindi siya nagdi-debate masyado dun sa quantile plot. Okay. So okay tayo with regard to the normality ng residuals natin. Okay, the next is yung mga outliers. Dapat tingnan din natin yun. No? Dito, in-explain ko dito that outliers are point siya dun sa natin na extreme yung outcome. Extreme outcome variable, yung sales value extreme. Okay, the presence of outliers may affect the interpretation of the model. Okay, kasi tumataas yung natin, yung SSR, yung sum of the squares of your regression, yung RSE natin. Okay, so madali ma-identify yan kasi yung plotting natin ma-identify yung outliers. No? So one way, guys, is yung kay Tukey, yung box plot. No? Makikita natin doon yung mga dots na outside your whisker, if you recall from your basic stat, mga outliers yun. Okay, but yung iba, guys, iba yung pag-measure nila ng outliers. Yung sa box plot, which was developed by Tukey, T-U-K-E-Y, yung tao, no? Ang ginagamit niya, I think 3 standard deviations. Basta yung computation yun, yung quartile 3 plus 1.5 times IQR. No? Okay, I don't know if you recall that. Quartile 3 plus 1.5 times IQR. Tapos sa kabilang extreme naman, sa kabilang whisker, sa lower whisker, that's your quartile 1 minus 1.5 times IQR. So hindi ko na siya, guys, sinusulat kasi basic stat naman yun. I'm sure alam nyo pa yun. Okay. Then isa pa, guys, aside from outliers, yung leverage. No? Okay, ano naman yung leverage? A data point has high leverage if it has extreme predictor X values. So pag matataas yung sales, yung Y values, guys, possible na outlier. Pag matataas naman, guys, yung predictor value, yung predicted value, guys, then that's a candidate for leverage points. Okay, so may statistical formula silang ginagamit dyan. We will not go into that. Pero importante, guys, okay, ito, makikita natin, guys, yung mga residuals versus leverage plot, yung kaninang tinignan natin. Diba? Ito. Okay. So itong 26, no? Itong 179, 38, these are data points that have very high yung predicted values. No? Okay? And yung pag mataas yung predicted values, guys, then it's a cost for mataas yung residual nun. Mataas yung comparison niya with the actual data points. So ito yung Cook's distance natin. Yan. Cook's distance daw natin. Okay, so these are candidates for leverage points. Now, pag mataas, guys, yung ang leverage points, guys, dyan ang pinagkukuhaan ng candidate for influential points. So yun ang pinaka-ultimate, yung influential data points. Kasi pwedeng mataas yung leverage niya, pero not really an influential points. Ang binabantayan talaga, guys, yung influential points. And that can be seen in the Cook's distance. No? Okay. Ito yun. No? Sabi natin kanina, it's a value which inclusion or exclusion can change the result of your regression analysis. Okay, and associated siya, guys, with a very large residual. Okay, and that's measured by Cook's distance. Okay, may values silang ginagamit, itong 4 over n minus p minus 1. Okay, so, but we will not go into the computation. Okay, ang importante lang malaman natin kung yung isang point ba it's influential point or not. Okay, so yung Cook's distance makukuha natin dito sa plot number 4 yon. So 28, 38 and 179. Ito yung mga candidates for Cook's distance, no? Yung 5 naman, ito yung kanina, no? So 26, 179, 36. So ito yung leverage points. And notice guys na it doesn't mean kapag leverage point siya, it doesn't mean na influential siya. Okay? Excuse me. So not all leverage points are influential. Okay? So but usually kapag leverage siya, candidate na siya na maging influential, but not always. Dito ang naging influential lang 179, 36. Let me see this again. 179 and 36. Si 26, kasama ba si 26? Oo, kasama din pala. Sorry. So dito lahat ng leverage candidate din naging possible na influential data point din sila. Okay. Kasi minsan may mga leverage guys na hindi not necessarily influential. Okay, so sa plot guys, ang default niya yung top 3 na may extreme values ang pinapasok niya dun sa plot number 4, no? But of course, pwede natin gawin guys na yung option na to, id.n is equal to 5, yung 5, no? So i-run natin to. Okay, and you can see that 1, 2, 3, 4, 5 yung pinasok niya. Okay, si 179, si 36, yung may mga tataas na Cook's distance, and si 26, and then susunod si 176, no? Halos pareho lang ni 26. Tapos si 132. So these are the top 5 observations na candidates for influential data points. Okay? Yung kaninang prinat natin, nag-default lang siya sa 3. Okay, so all right. So, i-plot natin dito, mag-generate tayo ng, naalala nyo to? Model.diagnostic.metrics. Okay, do you remember this data? Ito yun, no? Ito yung, andito yung, yung fitted, yung residual, diba? Ito yung fitted value, yung residual, yung hat, ito yung ginagamit to measure yung Cook's distance, ito, no? Okay, so we're going to use this object kasi ando dun yung Cook's distance, no? Andito yung Cook's distance. Gagamitin natin siya. And then, okay, ito yung deployer natin. And then, yung function of top n, okay, top n 3, then weight is equal to Cook's weight is equal to that Cook's SD. So if you run this, okay, so ito siya, no? Ayan. Ito yung top 3 in terms of Cook's distance, no? Top 3. Okay, residual. Hindi ba binigay yung yung observation number? Okay, hindi binigay yung yung observation number para sana madaling makita. Okay. So these are the top 3, no, in a table form. Of course, pwede nating lagyan ng ng pangalan. Okay? Then okay. Ito yung sinasabi ko guys na from OLSRR, pwede rin tayong gumamit ng ng residual metrics, no? So yung OLSRR, remember before we use that for stepwise regression. So meron ding function na OLS plot Cook's distance bar. Okay, so bibigay nito yung bar plot ng Cook's distance to detect observations that strongly influence fitted values of the model. So let's run this. Bar chart ang ibibigay sa atin ito. Yeah, okay. So makikita natin dito guys yung Cook's D bar plot. Okay, ang threshold niya 0.02 ito. Okay. So yung sinasabi niya dito, mga normal to mga blue observations na to. Yung outlier, ito, yung mga pula. So, but not all outliers, guys, are influential points, na hindi lahat. Ito yung sinasabi lang niya na based on a Cook's distance of 0.02, yung mga points na to are considered as possible outliers and possible influential points. Pero consistent siya, no, guys, di ba? Ito, 179, 36 yata yung pinakamataas, no? Ang ano niya, 0.06 something yung Cook's distance niya. Tingnan natin dito. Cook's distance, 0.06 to, no? So this is yung number 36. Tapos 0.05, itong 179. Ito, 0.05 something. And then ito si 26.03 something. There, 0.03 something. Ito si number 26. Okay, so this is using the OLSRR package. Tapos pwede rin natin in chart form. Lagyan natin to. Yan, this is in chart form. Okay, although parang hindi naman siya mukhang chart. Okay, and then also, pwede rin gamitin, guys, yung aside from Cook's distance, meron din ginagamit na measure, yung DF beta. That's also used to determine kung may kung influential, like this one. So DF beta yung ginamit dito. So hindi ko na i-discuss masyado, guys, yung yung difference itong DF beta at saka ano. Suffice it to say, guys, that there are different measures. Isa yung Cook's distance. Tapos sa DF beta din, no? It's used to measure yung pinalaki ko lang ng konti. Ba't ayaw? Nawawala. Okay, ito na lang. Ito na sa plots dito. Yan. Okay, mas maganda pa dito. Alright. So, kung titignan natin based on DF beta, no? Andyan pa rin si 36. No? Si 36, this is influence diagnostics for the intercept and for YouTube. No? Kay YouTube, so consistent sila, asan yung kanina? 179 andito. Si 36 andito. No? Sila yung laging top notcher. No? So ito yung tinitingnan na beta measure. Pag medyo above that, then that's a potential na outlier at saka influential data point. Okay? So gusto ko lang i-discuss na hindi lang si Cook's distance, no? Ang pwedeng i-measure. Ang pwedeng gamitin na measure, ano nangyari dito? Parang hindi niya pinat. Okay, dito din, no? Ito naman DF fits. Similar lang yan sa Similar lang yan sa DF beta. Okay, ayan, 179. You can see that medyo consistent, no? Okay. All right. So, okay, what we have done so far, guys, is take a look at diagnostics for simple linear regression. Now, what I want you to do is to now use this for itong data pa rin natin to, but this time mag-multiple linear regression. So go through the process. Tingnan nyo, guys, i-plot pa rin yung mga different plots, yung scale location, yung QQ plot, ma-generate pa rin naman yon, and try to see if nakaka-address ba and test statistically kung nakakatulong ba, guys, kung kasi una natin, di ba, may problem tayo sa heteroskedasticity. But what if there are more variables that are being used? Ano mangyayari kaya sa heteroskedasticity? And then here guys, masasali ngayon yung ano, yung autocorrelation, no? At saka yung multicollinearity. Kanina hindi tayo nag-multicollinearity kasi iisa lang yung variable natin, no? Ito guys, hindi pa ito tapos, ano, hindi ko pa linagay lahat, no? Kasi I would want you to do it, no? Pero okay, ano ba yung dinagdag ko dito? Durbin Watson, ito for autocorrelation, no? Autocorrelation para makita kung yung mga residuals are not, they're independent. We don't want the residuals to be independent, to be dependent on each other. Gusto natin sila independent. But yung case na yun guys, it does not hindi siya issue sa ano, sa cross-sectional data. Kasi pag cross-sectional data, pwede nating baguhin yung order ng data. Okay, mas issue sa pag time series. Kasi pag time series, hindi natin pwedeng baguhin yung ano natin, yung order ng data, no? Okay? So kindly we do this, guys. Okay, so next meeting, we will just compare notes, no? So dito hindi ko linagay yung multicollinearity. Okay? So paki-check guys. Research lang kung paano ang clue dun guys, let me give you a clue. Gagamit ng VIF yun, no? This is the variance inflation factor. Okay? Pero importante diyan guys, tingnan muna natin yung correlation ng mga variables, especially ng mga independent variables. So paano yung correlation ni YouTube, sa newspaper at saka sa Facebook? Kasi pag highly correlated sila, pwede tayong magka-problema doon ng multicollinearity. Okay? We don't want the independent variables to be correlated. Ayaw natin yun kasi kumbaga in layman's term, mag-aagawan sila in explaining your sales. We want them to be as independent as possible. So kung may mga correlation tayo na kunyari 7.7, 0.6 o 0.8, the higher the correlation, the bigger the chance that our model will suffer from multicollinearity. Tapos guys, pag may multicollinearity tayo, blue pa ba yung yung model natin? Is it still the best linear unbiased estimator? That we're going to discuss next meeting. Okay? So request ko lang sa inyo guys, no, na i-run nyo to, tingnan nyo, i-test nyo kung yung diagnostics for this multiple linear regression. Tapos we will reinforce this on Monday. Tapos tingnan din natin yung tapusin natin ibang yung medyo may nabitin tayo dun sa ang tawag dito sa interaction, ano pa ba, sa quadratics, mabilis lang naman yung mga yun. Hopefully matapos natin, and then kung kaya pa natin dapat ma-interject ko na yung time series, no? And then guys, I might be asking for an additional class, no? Kasi looking at the number of weeks natin, medyo kukulangin tayo. So mag-i-request talaga ako ng maybe isang 1 or 2 Saturdays, no? Pasensya na para mas marami tayo ma-cover, no? Okay, with that guys, let me stop recording. Stop recording ko na muna.